These are the first 6 problems from the study guide for Test 3, Quarter 3 for Algebra A. So let's take a look at the first one. It's a review problem. It's asking us to write an equation in slope-intercept form that passes through the point, negative 8, 2, and has a slope of negative 1/4. So the first thing we're going to end up using is our point-slope formula. Remember, it goes this way. Y minus y1 equals m multiplied by x minus x1. So we're going to use this formula and substitute the numbers in there. So first thing I'm going to do is take the point. Now this point is, the first number is x. Now I'm going to put it in for x1, so it's going to go right here. And then this next value is our y value, and that goes in for y1. And our slope is m. And so it's just a substitution problem. So we've got y minus 2 equals the slope of negative 1/4 multiplied by x minus negative 8. And so from that point, I go ahead and distribute this negative 1/4 over this addition. Now I call this addition because minus negative, remember, that makes plus positive. So really inside the parentheses, you're adding. However, we're going to multiply the negative 1/4 over that addition, and it's going to switch the signs. And so we bring down our y minus 2. This now equals negative 1/4 times x, so negative 1/4 x, minus, now careful in that sign, and think of this as a fraction, 8 as a fraction. And so think of it as 8 over 1. It's a negative 1/4. So 4 goes into 8 2 times. You multiply across, you get negative 2. So that's why it's a minus 2 there. And then from that point, just one step here of adding that 2 to both sides. And it just so happens to cancel out that negative 2. And so what we're left with is just y equals negative 1/4 x. So there's the first one. You'll see one similar to that. And on the next one, it's asking pretty much the same question. It's asking us to write an equation in slope-intercept form. But this time we have a relation. It's described below here. And these are ordered pairs. So here's one ordered pair, 1, 1. Here's another one, 3, 7. So we've got 1, 1. We've got 3, 7. And then we've got some other ones over here. Now, I don't need all the points. All I need are 2 points. So I'm going to just stick with these 2 points. They came first. They're smaller numbers. So that's why I used them. Now I'm going to use this slope formula. Slope formula, remember, slope is the steepness of a line. When we're talking about steepness, we're concerned more with the direction that you go vertically. So we treat the slope as the rise over the run. It's a little saying that we use. And again, rise is on top because y's are more important when we're talking about slope. We're talking about steepness. We care more about how high up we have to go than how far over we're going when we're climbing a mountain. And so we go ahead and substitute the y values in for the y and y1. So I'm going to start with the 7 minus 1. Now since I started with the 7, I've got to start with the 3 because that comes from the same point. So 3 minus 1. We do some work there. That makes 6 over 2, which reduces down to 3, or 3 over 1. So we're going to use this slope, and I'm going to use one of the points. I'll use this point right here, and I'll substitute it into my point-slope formula. Y minus y1 equals m times x minus x1. So we go ahead and do this. We now have y minus, and then a 7 I'm putting in there. And then our m term is 3, x minus 3. And so I'm just substituting the point, 3, 7, in for the y1 and the x1, slope in for 3. We do the same thing we did on the last problem. We use the distributive property, multiply the 3 over that subtraction. So what we've got left is this y minus 7 equals the 3x minus 9. And then from that point we use the addition property of equality, which says if you add a number to one side, you can add it to the other side, and you keep the equation in balance. And so doing that allows us to get y by itself. So now we have y equals 3x minus 2. And that is our answer. Well, taking a look at the next one, it's asking us to determine whether a point is on a line. And so the line is defined down below, and so all you're going to do is take the x value, and you're going to put it in place of x. So it's just a substitution problem. Take the y, put it in place of y. And we're going to see if the two expressions equal each other when we do the work. Well, we'll go ahead and do that substitution. And and then do some evaluation. Evaluation is just simplifying once we get the numbers in for the variables, and seeing if the two expressions equal afterwards. So we do some work here. 35 hundredths times by 0 just makes 0. 10 times 1.4. Well, 10 times a number just moves that decimal point over one space, so we end up with 14 minus 14. We do some work there. 14 minus 14 makes 0, so the two numbers are the same. So when the two numbers are the same, you say, yes, the point is on the line. Alright, so there it is. So it's a yes in this case. And again, the reason is because when we substituted, we got the two expressions to equal. The next question, number 4 here, is asking us to find the x and y intercepts of the line defined below. And so what we're going to end up doing is setting one of the variables equal to 0 to find the other one. So let's set x equal to 0 first. And so when I set x equal to 0, it cancels this term out, so I'm just left with 1/8 y equals 20. And so when I go ahead and solve, I'm just going to do an opposite operation here. I'm going to multiply by the reciprocal, 8 over 1, and that'll cancel out these 8's. But I got to do the same thing on this side. Well, 8 over 1 is the same thing as 8. And so when I do that, I multiply 8 by 20, and I get my answer. So in this case, 2 times 8 makes 16. Bring that 0 down. There it is. The y-intercept is 160. Wow, that's kind of high up there. And so you can write the answer this way, or we could write it as an ordered pair. So the ordered pair would be 0, 160. So you may see it either way. And the ordered pair just represents the point where it crosses. The next one, the next intercept, we're going to set y equal to 0. So when we do that, we rewrite what we've got. Again, this time I don't need that 1/8 y because that equals 0, so I'm left just with the negative 4x equals 20. And so I do an opposite operation here. I'm going to divide by negative 4, divide by negative 4. And so when I do that, I'm left with an x equals negative 5. And so from that point, I've got my point. I can either write it this way, or I can write negative 5 comma 0. Your choice. And so you'll need both of them for the answer on this test. The next question is moving out of the review stuff and into what we are working on this week, and it's asking us for the solutions for the quadratic equation. And so when we find the solutions, the way we worked on it is to factor, or we could end up using completing the square, but we can just factor it. It's fast enough doing it this way. And so the first thing I'm going to do when I factor is I'm going to go ahead and set it equal to 0. Again, completing the square would work as well, but in this case, this is the method I'm going to go with. So x squared plus 4x minus 12 equals 0. And so I like this method because it works a little faster. See, if I could factor it quickly, I can get the answers a lot faster than I could completing the square. So numbers that multiply to make negative 12, but subtract to make 4, subtract because of this minus sign right here, would be 6 and 2. To make a positive 4, I need a positive 6 and a negative 2. And then from there, I set those factors equal to 0. So x plus 6 equals 0, and I end up doing x minus 2 equals 0. And so when I go ahead and do the work, I subtract the 6 from all sides. Over here, I'm going to add this 2, and I get the answers. So I end up with x equals negative 6 for one, and x equals positive 2 for the other answer. And this next question is asking us the same thing. It's asking us for roots. Roots are the same thing as solutions. So these two questions are the same. They mean the same thing. It's just that they're asking in two different forms. And so they equal each other. They mean the same thing. So you're basically setting x squared minus 8x minus 9 equal to 0, and you're factoring. And so when we factor this, we're ending up with an x minus 9 and an x plus 1. Now I know those are the right factors because I checked the outside and inside terms to see if they work. Negative 9x, 1x, those end up subtracting to make the negative 8x, so it ends up working. So always check that. Make sure your factored form works, and then take the factors and set them equal to 0, and then solve. So x minus 9 equals 0, and x plus 1 equals 0. So when we go ahead and solve this, I'm adding the 9 to all sides. And then over on this side, I'm subtracting the 1 from all sides. So I end up with x equals 9, And over on this side, I have -1. So those are our two x-intercepts. Two solutions, two roots, in this case is what they're asking for. So part 2 will have the last 3 problems.